It's quite strange. Okay, basically it's 14 point.
Yeah, so it's a larger angle because it's a greater reduction.
Yeah.
Okay.
This is a 1 to 4, wasn't it?
Well,
that was
this is the one.
So to work out the tension in the belt.
Okay, we need, same thing.
Okay.
Yeah, force pump.
Okay, so what we know is obviously that we have a complete gear ratio of 10 to 1.
Sorry.
Because we've got 2.5 and 4, so we've got 10 to 1, so that will be going to 1, 4, 5.
1 for 5, yes. The speed.
Speed of the pump is 1 for 5.
Okay, so the power, same thing?
Yeah, we'll assume no losses because it's the worst case for its transmitting.
So this is for the smaller pulley or the larger?
The biggest one's on the pump again.
So we need the smaller one.
Oh,
this
sorry.
time.
Okay, you can take either.
It's the same, yes.
Yeah, go for small.
Just
So we said before that's going at 580. Remind me from the previous calculation.
the so same power.
Seems to be the same
15
calculation,
kilo.
isn't it?
Yeah,
It's going to be the same, isn't it?
omega speeds. What omega?
Speed's 580.
Same speed.
It's going to be the same torque.
So same torque.
Because this is talking
Because
shafts.
we didn't. Yeah, we assume there's no losses.
Yeah, I mean the tension will be different because it'll be a different
Diameter.
diameter.
So okay, same torque. Yeah.
Don't you repeat that?
Yeah.
Yes. But where we have the torque is the force multiplied by the radius. We have a different radius this time.
Yes. Okay. So force equals torque 2 force 1 2 millimeter and divided by radius. Yes.
Yes.
Which was
Half of that, but that's the. Is it diameter or the radius?
That's the diameter, so I times 2.
Okay, that's fine.
247.1.
So it's quite a bit more.
Big enough. Makes sense.
It's 5389.3. So it comes out as Newton.
Newton. Yeah, I think it makes sense because that's the one that's running.
It's running slower. Transmitting the same power, but it's all running slower because it's already been reduced. Okay.
Yeah.
Yeah. Okay. So now what we need to do
Oh,
is
we still haven't done the resolve the forces.
Oh, okay.
Yeah.
Okay. So if you look at the pump. There's a motor, which I didn't know, motor and the pump. Or we've done resolving for the motor, we have to resolve for the pump, yeah, sorry. That's right, yeah. So
usually we should do this direction. Right.
Yeah, we have to be consistent because don't forget that the pump and the motor aren't on the same axis essentially. Our X and Y's, as we've labelled here, that are not on the same, it's not the X is on.
Is it worth drawing up the... okay, this is the shaft.
So have we got the drawing of how it's arranged?
Requirement.
That one.
I don't know what the drawing is. Yeah, this
This
one would be better. Oh, this one. Yeah. Yeah. This one. So that's the motor.
We took
We assume.
our X was in the direction pointing.
Yeah. That's one. Yes. So we could get this one. We could get
I'm trying to express it for the benefit of the camera, but have to be consistent in the way.
Yeah. So that's okay.
So the motor, the X was pointing from the small to the large.
Yes.
The X-axis was in that
So
direction.
so it's good. We calculate this one. Yeah.
And the Y-axis was actually in the direction pointing from the shaft to the pump.
Because
Okay, so that's our X-axis
this
pointing.
one, the shaft.
Yeah.
is rotating in which
Also,
direction?
it's direction
So
and
then
also
you
it's
vertical.
this
That's what we
this
need
will
to be
be,
consistent about.
and so it'll be here. If
Yeah.
we so
So from our,
if,
essentially,
yeah,
we've worked out the depth from the top,
yeah, we like this one,
Yeah.
and then so
and we've called that direction X.
yes,
Okay.
yes. That's
So
We've
one.
called that Y.
And is it y? So it will be if it's this one. If it's y is here, then it will be yeah.
Well,
Now
Y,
We can
essentially,
change them.
if we reach
X
y
is
to
that way
here.
and Y is that way, isn't it?
I think y is yeah.
Y is this direction.
direction. So that means we'll have to
Direction
change the
Y is
should
towards the
be-
pump, yeah.
Negative.
Yeah, because if you like this way to the,
Yeah.
then it will be.
Or we can change the
Connecting.
axis.
But normally, if you like just the standard x y only.
So you want that one to be negative, yeah?
It's fine. We just
And y.
keep, we just keep it should be
We
fine.
need
If
to
we
be consistent.
standard.
Yeah, exactly.
Okay, is that,
Okay, should we just...
draw the shaft.
This is the shaft,
Mm-hmm.
okay? That's the bigger pulley from the motor,
Mm-hmm.
right? Okay. Which direction should we assume X and Y?
X is that way.
Yeah, this.
X this way
Mm-hmm.
and Y that way,
Mm-hmm.
right?
Let's
Yeah,
see.
I mean, in essence, we have
So what these three.
I think it's probably easier just to say that we have,
Mm.
I mean, I'm regretting saying X and Y now. It would have been easier if you just said
Horizontal and vertical.
Because yeah, we should assume this which direction we were running.
Exactly,
Which
yeah,
direction
yeah.
running, then we'll see what would be.
That's
It
right.
could be like this way or something. We assume if we go this way
In,
and
it doesn't matter because you can switch
yeah,
the
but you
motor.
have to keep it
Yeah, I
constantly. Just like we assume if they running this way,
Okay,
Mhm.
so
then
it's
it will be
clockwise.
running this way and
Clockwise,
this
that way.
one,
Mhm.
and it will be run this way. So it will be
So
here.
the smaller pulley on this side
and it
Mhm.
will be
will be
this.
turning clockwise as well from
Mm,
this end.
to the end. This
Right.
the center.
Mhm.
So it will be
This is good.
So since you, what they have,
I think the y-axis is different. It should be because it.
probably easiest if we do it, if I just draw this where we have the shaft, where we have the two pulleys. Ignore the pulleys actually, just say the, so we have that's the F, M, X, and we say that that would be the
That's
M, Y. And in this
no
case,
negative and good.
well, what we could
That's
say, I
the-
mean, if you want, if you want
No, just make sure, yeah, we're right on this diagram.
okay. And for this one, what we're saying is that there would be a force in this direction. I mean, if we just take the X and Y's as being,
I think the S-Y is just.
That
like-
was- essentially
Just give it a unit, FPY, as long as it's in the same.
essentially what, I'm actually going to, let's say actually FPX is what we've worked out there, and in this direction it's FPY, but we have
So
to,
why is that? We have to
The
change.
XY should be different because
Treatment-
it's just
treatment.
like this way.
So do you
So
want
it's
to,
if it's the XY and next one should be Y.
would it be confusing them?
No, I think it was clear from this figure
Mhm.
because we defined is here is X, this one is X, this one is Y, double is that. Then if we just assume it's running.
This will be X.
Oh, sorry. This is will be X.
Mhm.
Then if you running this way, then they have a force here.
Yes.
Mhm.
So that's where
Fx
we
is
yeah,
positive.
we calculated
Therefore
it
it's
that is X, Y.
And
And
then
here,
y is
because
negative.
it's running here, it's turning this one, it's turning one, but so I assume the force is like this one.
So what we actually have is the greater force is actually the FY and the negative.
Yeah, so they just like,
It'd be
Yeah.
positive though, wouldn't it? 'Cause it's
yeah,
going
yeah,
upwards.
all positive, all that. But
So,
it will be, this one should be not X, should be Y.
mhm.
Yeah, that's